Hello world and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart, architect at OneLink. Today we're going to be taking a look at star schemas and how you can use Data Factory to build one of these. Hi guys, I'm going to take another look at Azure Data Factory today. And today we're going to be looking at a little bit more theory around how you can use Data Factory to build ETL type workloads. Today we're specifically going to be looking at how to build a star schema, and then I'm going to show you an example of one of those that I've constructed in Data Factory. But first, let's go look at a slide deck, review some stuff, and then we'll get an idea of what a star schema really is and what it's trying to get at. And then we'll go over to Data Factory and take a look at how I implemented one of these by aggregating a bunch of data and kind of pulling it together into something that we could use for a star schema. So last time we talked about how to build an ETL workload in Data Factory. We looked at it specifically more of the things around the E and the ETL and then some of the T and the transform. So it looked something like this where we had data coming from data sources and we were putting that in some kind of landing zone. Then we were using an extract process to move that from a landing zone of some kind into a data lake. And then we worked on the transforms where we were moving the data around in the data lake, but we were also doing some data manipulation on that where we were transforming the data, maybe doing some joins, aggregations, whatever that might be. And then from there, we take that data into some kind of system data that we're going to be then exporting into an external data store, which then can be used for reporting. So for today, we're primarily going to be looking again at some of this transform and extraction, which we're going to be looking at it from a different angle today, where we're going to be looking at it as what we call a star schema. And that is where we can take this and produce a set of data that is in a form that makes for doing large data workloads very fast and very efficient inside of the Data Factory context or any other kind of ETL context. So let's talk about what a star schema is, and we'll understand why it's called a star schema in a moment, but let's talk about the more fundamental building blocks of this. There's really two kinds of data in a star schema, and that is what we call fact data and that we call dimension data. Now, this is not a new idea. It's been around for a long time in data processing. So it goes back probably to some of the early days of data processing in the 60s, but this idea is really useful in building out, data that's highly performant for doing a lot of different kinds of aggregations and queries inside of something like Data Factory or Databricks, whatever it might be. So it starts with fact data. Now, fact data is typically transactionally oriented. So we typically start with some kind of transaction, and we can summarize that either through snapshots. It's basically looking at it over a period of time, or building some kind of summary around some kind of dimension or something like that, such as summarizing data for a given state or given zip code, whatever it might be. So that transaction data is basically capturing it in a transaction that is written once and read many. An example I like to think about is a ledger. So if you think about a ledger, you have debits and credits, and each one of those debits and credits might have other data associated with it. You might have dates and descriptions, but it's a single record capturing a debit or credit that you write once, and then you might read it over and over and over again. You don't go back and change it. You don't go back and alter that data or delete it. You just keep it as it was recorded and just kind of move it forward. And that's kind of the nature of what a fact is in a fact table, which is basically a record of transactions in a star schema. And again, like I said, you can do summaries against transactions or snapshots against transactions, but it's ultimately something that's transactionally oriented that you're kind of recording in a forward moving manner. So over time, you're going to be adding lots of new data to this, but you're not going to be altering it or deleting it and going back and altering that table as it moves forward. Now, a dimension, on the other hand, is not transactionally oriented. So this is your non-transactional data that's typically represented by things that aren't recorded as transactions. And some examples of this might be time. Now, as I've said, time is sometimes recorded as part of a transaction, but you might have a dimension table that has that time component blown out. So you can look at the dimension table to get something about the month or the week or the day of which a particular transaction happened, but you wouldn't record that in your fact table. You just record basically a timestamp, and then you would correlate that timestamp over to a dimension table about some kind of date data, whatever it might be. Another common one is entities, and this would be things like geography. As I mentioned, for a transaction, you might have a transaction that is summarizing data for a zip code, and then you would have in your dimension table a zip code that would have information about that zip code. So that might be, what city is associated, what state, what country, what demographic, and things like that. Or it might be something around a particular product or product type or something like that. Those are the kind of entities that you would have. Now, the ranges is another one that's often used, and this would be ranges of numbers. So if you can think about, maybe it's a pay grade. So you have people that make between $20,000 and $50,000 a year, and that's a range. And then you would have data about that range inside of your dimension table. So dimensions can be composed of a lot of that kind of information, but it's basically non-transactional data. And we'll look at an example of this, but why it's called a star schema gets interesting because it takes on the shape of a star once you start to look at the tables laid out on a more of a flat representation of what we might be used to when we're looking at relationships between database tables. So we start with the fact table in the middle, and the fact table really is going to have our transactionally oriented data. But notice that it's got a couple of foreign keys here. And these foreign keys are foreign keys to our dimension tables. So we have 3 dimensions that we're going to be having in this off this particular fact table. And these are going to be one-to-many relationships between the dimension and the fact table. So a fact table typically will have one or more foreign keys related back to one of these dimension tables, and these are going to have the primary key to this foreign key right here. This is going to have a primary key to this foreign key right here, and this is going to have a primary key to this foreign key. And the reason it gets a star schema going on is typically you have this kind of center hub, if you will, the fact table, and you're going to have multiple dimensions kind of hanging off of that, and that kind of represents the various spokes in the star. So you end up with what they call a star schema because of this. Now, with a star schema, you typically don't get more normalized than this form right here, and that's because this particular form allows us to key everything basically off of the fact table and not have to navigate multiple depths of tables to get particular information. So this is not normalized data. It's more denormalized data, but this gives us the ability to create a transactionally oriented table format that's going to be very fast for doing data summaries as well as data transforms and other kinds of queries against this data, so that we can build very quick reports and very quick transactional oriented data representations from this data format. So this is one of those things that can be kind of hard to get your head wrapped around, is when you start to look at a star schema in a particular database context or in a data lake, whatever it may be, because what this does is it's trying to optimize data for a specific kind of workload. Now, that doesn't mean that you can't normalize it or represent it in other forms and other data systems, but whenever we're working with ETL type jobs, this particular kind of representation is designed for performance. And so if we need to represent our data in another way, we might end up building multiple star schemas in our data lake so that we can have a representation of the data that's going to be very optimized for specific kinds of queries. So with that in mind, let's go look at what I'm going to be showing you, how I built this out inside of a data lake using Data Factory. And that's going to be my example that I'm going to be showing you once we actually go over to the Azure portal. So for the demo today, what I'm going to look at is something that I've been working on over the last 2 videos. In the last 2 videos, we looked at how to get data extracted from my firewall. And then I talked about how I did some transforms on that. And so what I'm dealing with here inside of this table is firewall events. So this is going to be things that happen on my firewall that I want to record. And that's basically the transaction that I'm looking at. So my firewall event happens between whatever the client may be and my firewall. So that's a transaction that's happening on the firewall, and I'm recording that inside of my fact table. And so my fact table is basically aggregating 2 kinds of events that happen according to the way that my firewall logs data, and bringing those together into a single table that I have a single representation of the data in a tabular format. And that's what I'm using for my fact table here. And it has things like port numbers, policy IDs from the firewall. It's what was the country of origin for the server or the client, or what is the address, or what is the blocked and flagged status of the data, and things like that. And there's a lot more data in there. I didn't list it all here for simplicity's sake, but the firewall events is my fact table. Now, off of this fact table, I have 3 dimension tables, and these are going to be key different. One of them is a ports table, and this is just a list of ports and basically what their usage is. So it's a common port number, such as port 23 is often used for SMTP, or port 80 is used for HTTP, etc. And it's basically just giving me information about ports, particularly server ports that are commonly used for different kinds of protocols and servers and that kind of thing. Another one would be countries. Now, this would be countries and the associated name. So it's basically looking for the 2-digit code that is recorded in the event table and giving me information about that country. I'm only giving the name, but if I wanted to put like the capital or the population or things like that in that country table, I definitely could do that. But I'm just using a single dimension table here that just represents the name of it, which is fine for this particular demonstration. And then I'm also representing the firewall rules, and that's being what's keyed off of this policy rule ID right here. And that's basically giving me the rule description and whether or not that rule is supposed to be blocked and supposed to be flagged. And then this tells me whether or not that particular event was blocked or flagged. And this is just describing you're supposed to block it or flag it. And if it didn't get blocked or flagged, then something's going on with the firewall. But this firewall rules table is another dimension that gives me information about the actual rule that happened for a given firewall event. So this is my star schema that I'm going to show you how I implemented it inside of Data Factory. We're going to look at some pipelines and some data flows that kind of give me these dimension tables, as well as continue to work with this particular data flow and pipeline that gives me this particular firewall events fact table that I've been working with. So now I want to look at my data lake and my data factory that I'm associated with that. And this is where I'm building out that fact table and I'm building out those dimension tables, as I mentioned. So this is pretty straightforward in that what we've already looked at concerning the fact table being the firewall events table. Now that's one's just bringing 2 different data sources together. One is what they call a session event on my firewall, and the other one is called a firewall event. And it's basically joining those 2 together into an output, which is an aggregate of those 2 that represents the subset where the overlap between these 2 is, which is what this join does. But it's given me the superset of columns that I need to really look at this as a transaction. And one of these, the session one, tells me what the IP information is, the port information, and so on. And the actual firewall data is telling me what the firewall policy ID was and all of that information. And that is what ends up in my fact table. Now, I've already looked at this at one level or another in a previous video, which I'll link in the description below. And I'll go into detail about how I got that data and transformed it. But mostly what I'm looking at here is the other things that I'm going to be building, which are the dimension tables associated with this particular fact table right here. So the first one is the firewall rules. Now this one I'm actually using a data flow on, and this is a fairly straightforward data flow. It's not really doing a whole lot. So it's using the firewall rules that I have defined here. Now, my firewall rules are pretty basic. I'm doing some geo blocking, doing a bunch of allowed ports in a block all, and these are prioritized, top to bottom. First match wins. So if it's originating or outbound to a country that I don't want to interact with on my firewall, I just block it. These are all allowed ports, and then anything that's not allowed is explicitly denied by this block all down here. And these are all represented by a JSON file that gets picked up and put into my data lake. And so that's pretty straightforward. So this is basically coming into my data lake. I'm doing some transforms on it, and then I'm ultimately writing it to a sink. Now my transform is just looking for some basic data. And the transform is just basically stripping out columns. And so it comes in looking something like this. This is the hierarchy that is represented by the JSON right here. And I really only care about the rule ID is the rule telling it to block, is it flagging it, and what's the description. I don't need the conditions, which is the kind of the logic. I don't really need that. I'm kind of stripping that out. And that's what this particular transform does, is just removing a bunch of columns and then ultimately writing that back out to a sink, which is my firewall's rules sink. So very straightforward here. Not a lot going on, but it does produce a 4-column table that is a dimension table. It's actually a very small table. So if I come over here to the actual pipeline that produces this, it's this run firewall rules. That points over here to this to the data flow. And once I invoke that, it reads it from that JSON file in my data lake and then writes it to a Parquet table in my data lake. So if we want to take a look at that, it's pretty straightforward. So if I come over here, this is the kind of the raw, the bronze tier, if you will. This is my gold tier, if you will, or sorry, silver tier. And if I want to see the output from that firewall rules, I can come down here and look at this Parquet table. Now, if I download this, this is called part 349. Let's just download this. And I already have this Parquet viewer right here with the, okay, I already have a copy of it open. And this is what it looks like after it's done. So the JSON gets moved into this Parquet table and I just have 4 columns in it. The table, the column that I'm most interested in is this rules ID table right here, because that's the key from my fact table. And it only shows up once here, but it's going to show up a bunch over in my fact table. So this is the correlation between the fact table and the dimension table, where I only have the primary key here and the foreign key over in the fact table. So this might get represented over and over and over in the fact table, but I only need it once here because this is not a transactionally oriented workload, but it does give me information about that particular rule, whether or not it's a block rule or an allow rule, and whether or not it's a flag rule or a non-flag rule. And there's the actual description. I don't need to see the logic per se. I just need to know, okay, this is SQL, allow SQL, or allow SSH, whatever it might be. So let's look at the other two, which are a little bit different. They're not a radical departure from this one. The only major difference is they're not using data flows to do any kind of transforms on, because I'm basically just taking data from online data sources and importing it into my data lake without doing any transforms on it. So I don't need a data flow to do that. I can just use a pipeline. So the other two that I'm working with are just CSVs. So they're just comma delimited or comma separated files. And so this is the country table that I'm getting country information from. And this is an online data source. And this is an online data source that lists a port and its common use. So port 23 would be for Telnet, port 22 would be for SSH, or port 21 for FTP, and so on. So those are the kinds of ports that I'm interested in here for this particular data that this is representing. But because this is already in a table and it's already in a format that I can use, I don't really need to do any kind of transforms on it. So I'm just basically going to take it as is from the CSV and put it into my data lake, but I'm going to do a type conversion on it, basically just put it into a Parquet table. So to do that, I have 2 pipelines that work with those 2 CSVs, and they're pretty much the same. One's get ports and one's get countries. And so if I come over here and I look at how these are working, they're basically just doing a data copy. And one of them is working with a source and one of them is working with a sink. And these are defined by these data sets right here. Now my source is working with this data set right here, and this is pointing to a CSV file. And this then uses a connection that defines where it's coming from. So this is where I define the URL right there. And this is the base URL. It's just the pointer to that file online. And I don't need a relative URL because it's just fully defined right here. If I had multiple files from that same base URL, then I could do that, but I don't have a single one. So everything's wrapped up in that base URL, and it's coming in as a CSV. The data set defines the format. The actual connection defines the actual place where that's coming from. So if I come down here to linked services and looked at these are basically pointing to that source online. If I had multiple sources coming from that, I could have a relative URL defined by the data set, but I'm not doing that. And so that's why I had those defined as such that I have a port CSV and a country CSV. Those come in as data sets right here, countries and ports, and those then import a schema, just like we saw right there. So, the countries has if I import the schema, let's get this, refresh this one a little bit. And this should have a schema of name and code there. That's better. Hadn't updated that. And this one has the port description and protocol. And down here on ports, the country has the name and the code. And then those get ultimately written to a Parquet table, which is defined by another data set, which is the countries underscore sync and the ports underscore sync. And it's basically just taking the data as is from one table and putting it into another table format without doing any kind of transforms on it. So if you don't need to do transforms, you can just use a pipeline to do that. It can convert data table formats from one to the other, but it can't do the data transforms, and that's what you need data flows for. So in this case, I just have a pipeline for the copy of data from the port source and the country port, and ultimately put that into a Parquet file, which is then a part of my silver tier that is represented inside of my data lake. So if I come over here to FW data, which is my silver tier, I can see that I have two folders here, ports and countries. My ports right here is a Parquet table 769. So let's just download this, and let's get the one for my countries, and we'll see this one here. And let's open up these inside of my Parquet viewer here. So the Parquet viewer is right here. Let's look at this one right here. Okay, there's my Parquet tables, and let's pull in this this table right here. And this is my ports table, and it's basically the same as a CSV. It's just a Parquet table now, and so there's no data transforms on that. And then let's bring in my country table, which is going to be basically the same thing as the CSV in this case, just the country name and the code associated with it. So those are my dimension tables there. So in this case, I am using my data factory to not only get my fact table, but I'm also using it to build my dimension tables too inside of my data lake right here. So that is what I'm doing to represent my star schema right here inside of my silver tier, by way of doing those different pipelines and transforms to ultimately give me data that is related to this fact table right here, which is going to be the majority of the data. But these particular dimension tables right here are smaller data sets that correlate to this particular data right here. That is going to be the log oriented or the transaction oriented data that I'm going to be using for my different kinds of representations that I'm going to be producing when I actually go to do the load portion of this, which we'll talk about in our future videos. So today we looked at star schema, and we looked at how I'm using Data Factory to produce that from multiple data sources from multiple places online, pulling that together into a single point of data aggregations that is represented by a star schema, but here it's in a data lake. So we're going to be working with this when our future videos, we're going to be taking this, doing some aggregations and other kinds of things that we can then take and use for external data sources that will be used for reporting. And that's something that we'll look at in other videos as well.
If you like this content, please consider visiting us online at www.wintellect.com, and there you can find about services that Wintellect offers, including training and consulting services. Also, please consider subscribing to this channel by clicking on the subscribe button and clicking the bell icon to get notifications when new content becomes available, and also comment down below. You can also follow me on Twitter at @TheOneMule, and also follow Wintellect on Twitter at WintellectNow or at Wintellect. We are constantly posting things about Azure-related technologies and things related to software development. You can also reach us by email at consulting@wintellect.com. Until next time, thank you.